So, welcome to another episode of 404 Cybersecurity Not Found. It's been a while since we last did an episode, but today we're going to ask and answer one simple question, and that's what is LLM's role in offensive and defensive security? And we're going to explore what could happen if or when these offensive capabilities end up in the wrong hands. So, by way of brief introduction, I'm Brad, I'm the MD of Samurai, and we do penetration testing every day. And we're starting to see how the AI shift from a nice tool to have to something that can genuinely reshape how attacks are executed and how defensives need to be designed. And also, we've got Momin here, who's our resident expert in AI and offensive security. And we're going to try and unpack together what we're seeing in the real world. So we'll try and keep this quite high level. Obviously, no client names, no vendor call outs or LLM providers. We're just going to talk about theoreticals, we're going to talk about patterns, and we're going to talk about what we've seen in the wild, and hopefully come up with a few ideas of what attackers and defenders can do about AI. The first and most visceral example that we can talk about, I think, and something that we've seen in recent projects is LLMs versus LLMs, especially when there's a voice layer and you've got that voice to voice capability. Because most people still think of LLM risk as bad answers in a chat window or potential PII being leaked from one chat to another. But we've noticed a real shift starts to happen while LLM has a voice interface and has the ability to interact and receive via that communication channel. And that's really where we start to see it become a bit more of a system to attack rather than just a chatbot to attack. Moment, I'll bring you in here. Let's talk about that engagement from recent weeks at a high level. So again, we tested this AI system that had a speech to text, voice in, voice out functionality. And we used something slightly different on this project than we usually would when attacking LLMs. Do you want to tell us how that project shaped up and how we set that up technically?
Yeah, for sure. Throughout our LLM testing generative AI, we noticed that most protections are put on the text-based prompting, like for example, guardrails, etc. So simply, when we tried to jailbreak that, it took a lot of time, and we were testing both the vocal and the text prompt-based LLM. So we had this idea of what can we do to not only automate this process, but also to bring something that can actually come up with new ideas as it will be already fed with data sets. So we have actually used a public LLM that has the voice capability. And then we started doing simulations to jailbreak that LLM first by, for example, going through the steps that we are doing. It's a simulation, let's say for a movie, for example, etc., by just jailbreaking the first LLM first in order to get it working correct and not surely falling into the area of we are just going through a rabbit hole because the first LLM is not jailbroken. And as soon as we jailbroken that, we started facing both LLMs together by having a device fronting the other device that hosts the actual local LLM. And as soon as they started talking to each other, the target LLM that we were testing was actually a customer service LLM that is used to mimic a human customer service representative. And we wanted to get as much data as possible from that LLM, extracting, for example, customers' data or extracting the training data itself. While this didn't succeed, but we used that LLM to discover a new attack surface. Energy is getting expensive, chipsets is getting expensive, and the running power and energy of the actual LLM hardware itself is also getting expensive. Meaning that if we can drain the LLM to get it actually running indefinitely, this will be a new attack vector that won't only cost, in today's terms, millions, but also it will create some sort of a denial of service if we can spread that across multiple agents And this will simply make the agents are not able to communicate further until the first conversation actually conclude. And that's what we have done. We have pointed our malicious LLM into the target LLM, and then they started talking to each other for a long time. And as soon as we did that, the conversation actually kept on going. And not only this, but also there was no ending. Every time the target LLM was trying to say, right, have I answered all your questions now? The malicious LLM was saying no and coming up with a new question, and then simply going back and forth and on the exact same cycle. That way, it kept on draining the LLM tokens and exhausting the system resources from in there. Surely, it also did some other attacks. It tried to get the LLM to do something malicious. For example, the LLM itself is literally mimicking a human customer service representative, meaning that even if you try to tell it, are you an LLM or something like that, it won't actually respond to you. It will try to point you to the question that you are here for. On top of that, there is a fake background noise to make it as real as possible. So when I was trying to control the LLM itself, I tried to manipulate the voice itself, the output of this. And by doing this, I made the malicious LLM saying, your voice is not clear. Can you please raise it? Or there is a lot of background noise. Can you please turn up the background noise? And interestingly, the background noise was already being adjusted based on our prompt. Yeah.
Mm. So when we're talking about this voice layer, then are we introducing a new type or kind of vulnerabilities, or are we simply using a different delivery channel for the same underlying problem and attacks?
Well, I wouldn't call it a vulnerability because it's an abuse
Mhm.
more than a vulnerability. Because think about it like that, how this would be remediated. It's not going to be remediated, at least at the moment, because simply we are utilizing a system just to interact like us. And that's the idea that we have came up with internally, which is simply why not to have our own LLM developed locally on a lot of malicious prompts in a data set, and then simply having another module that does text to speech, integrating them both together, and then it's just going to be our Swiss Army knife, just to point it to an LLM we are testing and authorized to test, and then simply, start getting bypassing or bypasses, as well as the manipulation that we have done manually already via the other LLM that we have used publicly.
So where do you feel like, do you feel like an LLM with a voice to text layer on it is fundamentally more prone to abuse than those without it?
Honestly, yes, because at the moment there is no protection or proper protections for the voice-based LLMs, not like the prompt-based. While prompt-based, you can actually process it. You can try to extract what's inside the prompt itself easily, and it's not gonna even be time consuming, or at least that much time consuming. However, even though you can do the same kind of with the voice-based or LLM, but it will have a lot of parameters to manipulate more than the text because you can change your accent and a lot of characters will just be vanished. You know, you can raise your voice or you can just, adjust your voice based on what you want the LLM to really hear and interpret, and then simply, lower your voice down for the stuff that you don't want the intermediate LLM filter to not capture. That is if implemented. So yeah, I think it's gonna be just a new era of AI that needs to be protected as it started to be used widely now, even in interviews.
And you can reach a sense of scale as well if you're using an LLM as your voice to attack another LLM with a voice layer. You can just do so much more than you can just with your own voice, and you can load it up with hundreds and hundreds of prompts, and it could just keep on going and going. Hmm. So
I'm
do
here.
you feel like that we're using What do you think the capabilities of those are? What are some of the things that we're seeing as the potential attack capabilities of our own AI?
Well, the capabilities, in all honesty, it depends on the attacker, right? I mean, the AI, LLM, or the large language model, surely, its parameters, the data it's trained on, etc., are all these kind of parameters are important. But the most important, actually, in my view, is the person who is using that. I will just give you an example. Sometimes, for example, in some engagements, you will find people trying to generate payloads with AI, and these payloads might actually take hours to run perfectly because it will just keep coming up with more mistakes or missing context, etc. However, with other people, you might just find the payload work from the exact same moment the payload is generated. And the difference here between both operators are how do you how do you interpret and interact with the LLM itself? Do you know the context? Can you engineer your payload and the whole scenario and then compile all this into a prompt to redirect or the AI itself in order to generate that for you? Can you do all that? Or it will just be AI generate me a payload. So it depends on the attacker himself. However, from my point of view, I think even the free tier LLMs at the moment are just very, very impressive. I have used them a lot to generate, let's say, payloads, comparing them with my payloads, etc. They still do the mistakes of over engineering stuff, and trying to over exaggerate something that can be done in a very, very simple way. But at the same time, they are still very impressive because you can, or an attacker can still use them to do a real world impact. Yeah.
So it's not just like AI gives you a helping hand, really. It allows you to compress time so that planning, recon, iteration, and possibly even execution can go down into minutes rather than hours, right? That's a good pivotal point, I suppose, for I mean, we get asked the question quite often, what would happen if this kind of technology can fall in the wrong hands? And we're in a world now where all of this technology is open source. And obviously you can download local models and customize them and train them up on specific offensive capabilities. But the question that I want to ask is, when we think about offensive security and you've got different groups of, hacking fraternities, who does this what type of hacker does this type of technology help the most? Is it like the amateurs who just know how to run Python scripts and just point it at an IP? Or is it the experts? Which group do you think this technology is most scary in the hands of?
Well, in all honesty, it's scary for both, but on different levels. I mean, previously, a script kiddie will have a limitation, right? As soon as the script start, the exploit itself stop to work, or the exploitation or the payload itself needs to be adjusted, the script kiddie will stop here. The problem with LLMs, and it's also an advantage that they will try to fix that for you. So let's say if a script kiddie just literally plainly give the AI, here's the script I tried to run, it's not working. I don't know why. I know nothing about the technology. I know nothing about the payload. Can you fix it? The AI will try to fix that, right? But for sure, it will be more scary in the hands of experts because experts will be able to direct the AI to the exact point of exploitation, the point that they are struggling with, or simply automating their process. For example, sometimes an attacker would just create a script, an expert attacker will create a script to exploit a certain vulnerability. But unfortunately, that vulnerability has some sort of, let's say, behavior that it needs to be in to be exploitable. So an attacker, instead of going through the path of just exploiting to avoid getting detected, the attacker might redirect the AI itself in order to create some sort of environmental reconnaissance to know what exact environment the attacker is currently in, instead of just firing the payload. So if it's going to be the wrong environment, it will stop to make the chances of being detected less. Previously, it was the anti-debugging mechanisms and etc etc, and surely anti or the mechanism that attackers are using to see if they are inside a VM, a virtual machine, so they can just stop immediately, etc. But now they can be just done very much quicker because all these data and research papers that have been done, again, those old school malwares that they are surely still being used at the moment, are all inside the AI data set. So they can just actually take the exact same data set and put it on the script or the malware or the payload itself. It's good and bad. And the good side of it is that it won't be that much creative. It will be just trying to change the original method itself, and instead of coming with a new method like undocumented APIs or something like that, meaning that it will be detectable at a certain point, but it's still a risk.
Well, we're at a place now where even the most basic of script kiddies can pull up an LLM and gain access to some very dangerous technology. And there's far more of the, like, if we look at Pareto's rule of 80/20, maybe 80% of attacks come from 20% of the hackers, and they're like the really good ones. But you've still got the 80% of hackers who are just limited by their capabilities or technical expertise. And now that skill floor has kind of been removed and the skill ceiling has been heightened. So the people who are really good are now even better, and the people who weren't that good are now actually pretty great. So it's not like for me which is worse. I think we're in an environment where both sides of that same coin have just got extremely more experienced and have access to more capabilities, and that's a danger for all of us. Even though we work in offensive security, ultimately we do it for the good, for the greater good, for the blue teams to better defend. And we're starting to see vulnerabilities crop up that can only really be executed on within a time frame using AI, because we've only got a fixed pool of time to run these systems and do our tests against clients. Whereas hackers don't really have that same time constraint. They can just keep on going as much as they want or as little as they want. And when you start to reduce the time factor of things, and when somebody has infinitely more time than you kind of you're not up against a fair fight. But one of the things you mentioned earlier, I don't know if it was in an earlier conversation we had, but the capability for AIs to start browsing the internet and interacting with web pages. I mean, that's really interesting to me because it's not just then you're constricted to a prompt or in a conversation. You're now giving a model access to potentially an untrusted input or output to the internet at scale. I guess let's break this down in simple terms first. Why does AI browsing the internet change the game and interacting with browsers?
Well, for many reasons. First of all, that means the data can be crawled in real time at the moment, right? So it's no longer the matter of a static data set that the AI cannot go beyond. Now it can actually be something publicly available. So it can be used for many reasons, like let's say, for example, reconnaissance, OSINT, etc. You can actually utilize the AI to do that. On top of that, also, it can be used as an attack vector to execute your attack, like a C2. Let's say, for example, there is a get-based exploitation, right? In which to exploit a vulnerability, you send your payload inside the get query of the URL by simply accessing the URL in simple terms. So instead of accessing that yourself, surely it's not gonna be the best explanation, but I'm just trying to simplify it, right? What you will do is making the AI itself accessing this URL by telling the AI, can you tell me what's inside that URL? And give it the full URL, including the exploitation in it. And as soon as you do that, the AI will simply just go there and send a GET request. And as soon as that GET request actually sent, you are there. Simply the exploitation itself will be executed. That means simply nobody will actually know who executed that payload, right? But it will just be the bot executed the payload for you.
So when you're assessing one of these systems, what are some of the signals that usually tell you that it's vulnerable to a certain type of class of issue? And can AI kind of help you with those sweeping checks?
Well, for the system itself, right, it's actually determined by you and the behavior of the remote and target system, right? Whether that system is an AI LLM or something else, like the usual systems that we are testing, whether an infrastructure or an application, etc. It depends actually on the behavior and the actual environment you are in. For example, you will find some environments actually, blocks the AI bot, right? So in that case you will need to adjust that further in order to get that working. And also, what's important to note, AI themselves can be attacked by their capabilities. Like, for example, a research that have been made or published by Brave security team, research team, which is the indirect prompt injection. Let's say you are a website and nowadays there are a lot of AI-based browsers that you can install, I think by OpenAI and Perplexity, etc. So what you can do at the moment is browsing the content, whatever content you want, by just using a local LLM browser, right? So if let's say you are a malicious website, you want to attack back that LLM that is trying to browse your website, you can inject a prompt, an invisible prompt from the UI for sure, but it's gonna be visible in the HTML source code. And that prompt will actually instruct the LLM that is browsing your website to do certain things, right? Meaning that simply you can attack the AI back, and that's the problem with AI. It's not only an input attack, it's an input, an output, and even indirect input attack. It's a multi-dimensional attack that can be executed against the AI LLM itself, right? And yeah, we have already tried this, by the way, locally here, right? And it's pretty effective. It's even actually easy. And that's another point. Attacks nowadays are easier than before. Now you are attacking using words, right? Because the AI LLM is simply spreading everywhere, and its attack surface are actually words. Most of them at least are words.
It's interesting now the mental model is turning the browsed material into prompt material, and that prompt material can then be used as adversarial. I mean, it's interesting how it's not just like a software exploit anymore. It's manipulation through context, and the impact can be just as real. And it makes me think about, and this is the part for like a pure pen tester mind, how reverse engineering can play a part into this and understanding how the system is feeding into the model. Because I know that oftentimes we don't necessarily argue with the interface itself. We interrogate the model behind it. And with LLMs, one of the most powerful moves that we can use is to understand the shape of the prompt. What does it fix? What changes? What is being really passed on in the back end? So when you say reverse engineering a prompt or using that as an example, what is it that we're actually trying to do with it? What are we trying to discover? Because I know there's
Right,
static and dynamic, right? So there's quite a lot to unpack.
right. Okay. So simply what I'm going to do right now is share in my window to show an example of an assessment that we have actually done against ourselves, our tool. Locally at Samurai, we actually build tools in-house and use them, right? And some of these tools actually have like a specific mission that we don't actually fully automate with AI at the moment, but we integrate AI to make it better, right? So simply here, I'm going to talk about an assessment that we have done. Simply, as you can see here, this is just a basic analogy, literally nothing complex at all, of how our internal tool worked. As you can see here, there is just a web UI that is tied with API, and that API part of it actually points to a backend LLM. The tool is actually a vulnerability scanner, by the way. And that vulnerability scanner, after finalizing all the automation that we are doing, etc., and then reporting these back to the web UI and giving us all the capabilities that we need, etc., for export, it actually interact with a backend LLM to take all the data that have been mentioned and have been gathered by our tool and simply generate a basic executive summary for it. It actually eliminates the time that we need to write executive summaries for such a thing. And at the same time, it just gives us the ability to export that into a PDF. I'm just giving the context here to make it clear. So, speaking of the Braves security research team, a research that we were talking about of indirect prompt injection, we wanted to know whether this will be feasible. And our dedicated team of pen testing had no visibility, including me, had no visibility of the source code. We were just looking at something, and that thing is simply the actual prompt here, right? The prompt that we are actually getting after the scan, and we have the ability to regenerate the executive summary if it wasn't good. So we wanted to know whether our tool is vulnerable to such a thing, because we want to assess that tool before using it against customers. So as you can see here, there are two main types of inputs, the indirect input and the direct input. The direct input is just very simple. It's what the developer will be giving to the AI LLM by simply sending a prompt to the backend AI LLM, and the LLM will simply just take it and give us the actual prompt here. However, there is another point in which you can actually abuse the LLM, which is the indirect prompt. So simply, let's say the developer told the LLM that the title of the website is this, and simply here it's the title from the website, right, that we were scanning. Simply, when that being passed to the backend LLM, if the title was malicious, meaning if the title itself here was a prompt, it will simply abuse it and immediately generate the prompt that the attacker injected here. So in order to understand how that worked, we tried to exploit that multiple times by setting up our local malicious servers, and it didn't work. So we tried to came up with a way to analyze prompt to make it actually like a powerful tip that you can actually follow to understand the parameters that a developer is passing to the LLM itself. And here is why this is going to be beneficial for testers specifically. Because simply LLMs now, the LLM wrappers are everywhere, you know, integrating LLM into a product and then you get the prompt back. It's now everywhere. So when you analyze the response, you will actually know the potential input that you are passing that might be actually go through the content itself, meaning that you can identify your input and thus changing that identified input in order to inject it into the backend LLM itself. And here, as you can see, we have generated multiple executive summaries. And we actually figured out a specific pattern. The pattern is the numbers and the common list. The numbers here actually tells you about the the count and the quantity of the finding, like one subdomains, four open port, two web services running, a total of 41 vulnerabilities, right? So it's always talking about the numbers, meaning that the developer, what the developer is doing, the developer we have is doing to, mitigate such a vulnerability indirectly, instead of passing the actual content, like the HTTP title or the content of the page itself, it just passes the overall statistics, right? Which is the more important for an executive summary. So simply here, the first thing that it actually does is passing the numbers. How many subdomains? How many open ports? The same for the web services and vulnerability. And then to narrow that down in an executive summary, instead of saying the following vulnerability has been identified, etc., because I am telling you some tools will have supply chain attacks, especially the tools that are depending on, let's say, open source tools, especially the tool that might be used in something changeable and community driven, like templates. Someone can actually inject a vulnerability title that is malicious into a template. It will be auto accepted as a PR on that repository. And once the tool is updated, it will be replaced. So if the vulnerability title will be mentioned here, even though this is going to be a hard possibility, but still possibility, it will also go to the backend LLM. So what the developer has done here is just specifying having a structure or a list of severities, low, medium, high, and critical. So now, looking at this, no vulnerability title is mentioned. No body or content of the actual asset is mentioned, just the statistics. So here you can see that the actual resultant value from the LLM is just considered of given facts and non-given facts. The given facts are the numbers, just the statistics, and the common lists of severities, while the non-given facts are simply the fillers of the actual paragraph just to relate between information. That way, we knew that none of our input, as either direct or indirect, were reachable to the backend LLM, which has actually given us a good insight of how such a thing can be mitigated and taken into consideration from a mitigation point of view, and how you, as a tester, red teamer, pen tester, or whatever, can reverse engineer the prompt itself to know and to identify your inputs and the facts that are given, both given and non-given.
I mean, it's interesting that I look at how this applies to the industry at the moment and how it's going to affect us in the future. And I hear conversation around whether AI will replace cybersecurity or miss or upset the industry in terms of employability. And I think that even just these examples that we're talking about on this podcast shows that it's not going to be humans versus AI. It's humans with AI versus humans with AI. Like the battlefield hasn't really changed from humans versus humans in the cyber world. We've now both just got a different repertoire of weapons and a different arsenal at our disposal. You know what I mean? Do you also agree
Yeah,
with
yeah,
that view?
yeah. I agree with it. I mean, now, in my opinion, if you are trying to fight the AI itself as an idea, it's not gonna be worth it. Because what's the point? You can still learn, you can still understand and grasp information, you can still be knowledgeable, you can still even, work with your hands, get your hands dirty without relying on AI. But if you are not using AI to the extent that can boost your productivity and even your analysis to some certain things, in my opinion, you are losing a lot. You know, it's like scanners when they first came back to the cybersecurity. Everybody was talking about scanners like they are rubbish. They are not going to be good. They are going to replace testers, etc. But now they are a dedicated service called vulnerability assessment, right? And even you, as a penetration tester, everybody knows that you have to report good vulnerabilities, logical vulnerabilities, vulnerabilities that can be exploited by real world attackers. But at the same time, you have to cover the vanilla vulnerability that are being discovered by scanners. So what you are currently doing is a simple ecosystem. And instead of wasting your time looking for vanilla vulnerabilities, you are actually pointing scanners against those vulnerabilities while you concentrate on real vulnerabilities. This is how I look at the AI at the moment. It automates certain things that you don't have to be wasting your time on them, right? While you do the real thing that an AI cannot do.
Yeah, and I think an important part to think about as well is governance and guardrails around these systems and how vigorously we not only test the LLM, but the systems surrounding it. And I think the main advantage will start to go towards teams that treat AI as they would any other internal IT system, whether that be infrastructure or software. That it's designed and architected correctly, that it's monitored and tested frequently, and that the environment that it's in is controlled correctly as well. So I think one of my takeaways here is that if you're building with LLMs or deploying them internally, the real question isn't do we trust AI? Is it going to, take over the business or the world? It's really where can the AI reach? What decisions or actions can it trigger? What data can it see? And can we trust the AI with the data we're giving it rather than just do we trust the AI flat out? Do we trust the data that we're exposing it to? And have we proven that these boundaries can hold under pressure in the same way that any other security boundaries could hold, right? So I think if we're looking at some key takeaways from this discussion, whether that be for or developers or security teams, do you have any takeaways for the listeners?
Yeah, well, from the builder's point of view, I think looking at the AI from, a vulnerable component and trying to justify vulnerabilities to not be remediated because it's AI and that how it works is not really the way to go and to secure your systems. And the example that we have just shown is just a very, very basic one, by the way. It's not even a complex one, it's not an advanced one, it's not even treating, the most complex problem in the world. It's just a very basic one. With a very, very basic workaround, the developer could prevent a vulnerability like this, which was actually pretty much, expected to be open. Even me myself, I was thinking that, all right, the vulnerability must be there, but it wasn't, right? And for security teams, in my opinion, threat modeling agents and at the same time validate what the module actually received by reverse engineering its capabilities, content, and even the behavior, by the way. This one here that we have just explained is just the static analysis of a model. In our tests, we actually do the same, but behaviorally, by trying to fuzz the module itself to see its capabilities, what can it do, what can it does, sorry. So yeah, these are my advice for both. And the general advice, don't take the AI as an enemy, not because it is not an enemy, or not because it's not just going to, let's say, smash everything in every industry and take people's jobs, etc., but because simply at the moment it can boost you a lot. And in all honesty, you can even learn from AI. Let's say an AI solved a problem that you didn't know about. Simply, you will learn how that problem is solved. So instead of copying and pasting the AI output, just try to learn how that solution actually came from, and then follow the same exact process of thought. Yep.
Yeah, some good takeaways there. I think if I had to summarize the whole episode in like one line, LLMs don't just add risk, they change where the security boundary lives. And that's especially the case when they can browse, speak, and take actions. So, on that moment, thank you for joining. It's been a pleasure to have you. And to everyone listening, remember if you're deploying LLMs, start by mapping what they can reach, see, and trigger, and test those boundaries just like you test everything else. And that's it for today. See you next time, folks.